Yeah, good. So yes, hello and welcome. My name's Rupert. Some of you, I know quite a lot of you. When I say quite a lot of you, probably half a dozen or so of you, a few more. I'm sure some of us have seen each other at previous BA RAG events as well, and we maybe not have talked, but you might have seen me around. I'm located in York. I'm a member of York Astronomical Society, and we used to have a bit of a sort of pilgrimage to the Space Centre whenever there was a BA RAG meeting. There's a couple of us here. There's Alan Pounder and Andrew Stevenson from York AS here in the meeting. So today we're going to be talking about Python with a bent obviously on radio astronomy. Because obviously there's a huge variety of capabilities here. I can see people here who've got PhDs, and I can see people who've got CSEs, which includes me as well. So you know, we're gonna have to sort of cover all bases. But the title of the workshop is an introduction to Python. So that's principally what it is. Now, it's going to go. I mean, I've allotted 3 hours. It might not go as long as that. I'm not quite sure, because a lot of this material I've never really presented before. So it may go quicker, it may go slower. If we're doing quite well and we don't get too sidetracked, there's a likelihood that we'll be finished before 12:30, which will be relatively good news, I'm sure. We will have some breaks as well. We'll have a sort of 10-minute break at maybe at 10:30 and 11:30, something like that, if we're still going at that point. With regards to sort of the ground rules, I mean, you can leave your microphone unmuted if you're not obviously talking to yourself, or your wife isn't shouting instructions to you in the background, then that's fine. But mute it if you want to sort of rattle on your keyboard or something like that, because it does distract everybody else. But the problem is with muting your microphone is, if you do want to ask a question, it takes, by the time you've found the mute button and you've unmuted it, the moment's gone. You know, it's so don't worry if it does take 10 seconds to ask the question and I've sort of moved on. Don't worry, just ask it and we'll go back and cover it. And I'm perfectly happy to answer people's questions as we go along, and hopefully I'll give you opportunities to ask questions as well at pertinent points throughout the proceedings as well. I think I mean, a little bit about me, just so you know what sort of level I'm at. I mean, I've been an astronomer since I was a kid. I got interested in radio astronomy probably about 10 or 12 years ago. Started reading books and did a little bit of meteor scatter stuff, and then got interested in hydrogen line stuff, and that was sort of prompted by the opportunity we were given. York AS were given by Leeds University a 2.5 meter dish, which suddenly plunged me into all of that. So in fact, Alan Pounder, who's on this call as well, he's been helping with that, and we've very slowly, unfortunately, been commissioning that up in the Yorkshire Dales. So it's a nice radio quiet spot, and we've got a nice location for it. And it's sort of getting a bit closer, and hopefully once COVID's gone, we can get that sorted out. So along the way, I've become really quite interested in hydrogen line stuff, and I've even sort of visited a couple of professional observatories, including the MIT's Haystacks Observatory in Massachusetts a couple of years ago, and that really sort of fueled my excitement, you know, seeing cryogenically cooled 30-meter dishes and all that sort of thing. You know, it's all exciting stuff, and for anybody even slightly geeky like me, radio astronomy is a fantastic opportunity to play around with mechanics and electrics and motors and electronics and software and all the things that geeks like. So you know, that's sort of my background. I work in controls, so I I'm a product manager for an American company who make control systems which are used by the military, used in medical applications for remotely controlling video equipment, basically. So everything from drones to endoscopic operating theaters and you name it. So it's embedded control principally, and I teach Python to engineers who use our systems. So most of them are fairly new to Python. Most of them are engineers already. Some of them come from programming backgrounds in C and other languages, and I teach them Python. So that's sort of why I'm here helping you guys. So I know a little bit about Python. I know a little bit about radio astronomy. I know a little bit about radio, motors, all those things I've talked about. I'm a bit of a jack of all trades, master of none, but I'm sure that applies to more than one of us here. So the topic of our talk today, right, before we move on, what I was going to do is just do a quick straw poll about people's ability, I suppose. And I was just going to ask a couple of questions. And the first one is, I mean, I'm not going to be able to judge the level of everybody and accommodate everybody, but has everybody here had a go with Python? Is there anybody here that's really completely new to Python, has never done any Python at all? Okay, so there's a couple of you. Okay, all right, that's okay. Well, that's fine, because we're going to start fairly simply. Are any of you actually sort of interested in other programming languages and done some programming of some sort or other, whether it be in Python or other languages? Are you all sort of, yeah? So that's where we're at. Now, what about things like Arduinos, PICs, single bus controllers? Who's played with those? Played, I mean that in the most polite way. Right. Okay. Good. Right. So we've got a good cross section, and some people have done some embedded stuff. Some people have done some PC sort of stuff by the looks of it. Okay. Good. Now, the materials that I prepared for the course, I have posted on a GitHub site. So let me just share my screen. I'm just going to move this Zoom call over onto this other page so that it doesn't interfere. And hopefully, with some help of the Zoom cleverness. Okay, so hopefully you should be able to see my screen now, everybody. This entire lecture is lecture. It's not a lecture. It's a workshop. It's a collection of bits, basically, a workshop. This is actually on GitHub. So if you go to this URL here, and what I can do, if anybody wants to follow along, well, they certainly can. If I stick this in the chat, if I can find the chat, where is it? More chat. There we go. Right. Send that to everybody. Okay. There we go. So if you look in the chat, there's a link there that should take you to this GitHub site. And this has got all the material that I'm going to be presenting. So hopefully you won't have to make too many notes or whatever else. And there's a number of ways of getting this locally. If you don't use Git already, then what you can do is you can go into this code section here, and you can do download zip, and then you can unzip it onto your local machine, and you'll have all of the bits and pieces. If you are a Git user, then it's even easier. All you do, to find out whether you've got Git on your machine, just type Git. You should get a page of stuff like that. And this applies to PC, Mac, or Linux. It doesn't make any difference where you are. If you do want to get a copy of it on Git, all you do, and those of you that use Git probably know this already, but you just do Git Clone, and then you go to here, and you can see here it says copy. This little button here says copy the URL, the HTTPS URL. So you just copy that. You then go back to here and you paste that in here. And so that's the actual where my repository is. So you just do Git Clone and you hit return, and it will clone a copy of that into the directory. So if I do dir, you should see that there's BA rag Python workshops there. So that gives you everything. And if I make any changes or updates to that, you can obviously update it using Git as well if you need to. It's up to you which way you do that. So let's have a quick look at the syllabus. We're going to be looking at Syllabus, the sort of starting point for all radio astronomy type projects is to obviously collect some data of some sort, and that invariably involves using something like an embedded microcontroller or a single board computer like a Raspberry Pi or whatever. So we'll be looking at those, and we'll be doing some little we're showing you some how to use those, because sometimes when you first embark on some of these types of computer, it's not always obvious how you do development on them. So hopefully I'll be able to show you a number of tools that will make your life easier to work with those, as well as how to implement, how to use obviously Python whilst using them, because that's the main topic that we're talking about today is obviously Python. A little bit about how to, we're going to show you, I'm going to show you how to interface to things like motors and switches and things like that, just to cut your teeth. Again, just as an impetus to maybe get you involved in it and have a go and you know, make some things work that way. We'll look at collecting data on both SBCs, so single bus computers, and also on a PC. How do you go about doing that? Then, obviously, once you've got your data, it'd be nice to see how you process that, how you filter it, analyze it, and then ultimately how you present that. And we're going to end with the presentation of data and how you show people that information and how you present your methods and your actual data to other people. Now, in a strange twist of fate, we're actually going to do this whole thing completely back to front. I know that sounds crazy. The actual process, of course, runs on here from 1 to 6, but the way I'm going to actually approach it is from 6 back to 1. And I didn't realize this until I spent a few hours working on it, and then realized that in order to show you all these things, I was going to have to use the presentation tools to do that. So it made sense to do it the other way around. So I'm going to start on the presentation of data, which sounds a little bit crazy. Where do we start? Now, what I'm going to be talking about is obviously predominantly Python. And Python is, for those of you that are very new to Python, Python is a language which is a little bit different from most of the other mainstream languages that you get involved with. Things like C and I mean, there's a whole host of languages out there, but a lot of us, if you come from an engineering background, have probably seen C and C++, and you may have done some PC stuff with HTML, Java, that sort of thing. The thing that's unique about Python is that well, there's a lot of unique features in Python, but the thing that makes it really nice is that it has a very simple syntax, which means it's easy to pick up. It's very easy to learn. You can teach somebody, well, hopefully by the end of these next couple of hours, you should be anybody that's never done any Python should very quickly be able to write some. The nice thing about it is that one of the things that makes it easy to learn, not only is that it's got simple syntax, but it's actually an interpreted language. What does that mean? Well, languages like C are compiled languages, and that means that you write some code, you then have to convert it into something that the machine can understand, and then run it on the particular machine. And if that's an embedded system, you have to sort of upload it and then run the actual code. It sounds fairly logical, but the thing about Python is that it's an interpreted language. Now, with an interpreted language, what happens is that when you write some code, or rather when you run the code, the compiler only operates basically on a line-by-line basis. So it's what's called just-in-time compiling. So it will read through your program literally line by line, and it will execute. It will compile it and then run it. So that sounds subtly different, but from a point of view of workflow and a point of view of speed of development, it makes things very flexible and very quick, and gives a sort of level of dynamics that you don't get in compiled languages. So that's one of the nice things about Python. It also is a very, very it's obviously quite a modern language. It's although it's been around for 20 odd years now, it still has a lot of modern features, which means that it's very high level. A lot of the complexity has been removed. So it's not like I mean, C is an old language. C has been around for a long time. Someone's asking here, is Python the modern equivalent of BASIC? Well, not really, no. BASIC is an interpreted language, so there are similarities there. But the big difference between Python and other interpreted languages like BASIC is that they are completely object orientated. So they do behave completely like something like C++ or Java in that regard. So that's something I'm not going to dive into today is object-orientated programming techniques, but once you get to grips with Python, you can start to really benefit from that. And that's something where BASIC is much more of a functional programming language, and therefore is not as extensible as Python. The other thing is that Python is basically just a framework sitting around a load of C code. So depending on what environment you're on, it's running some very highly optimized C code behind it. So again, interpreted languages like BASIC got a very bad reputation for being slow. And in fact, Python has a reputation for being slow, which is not particularly well deserved. And in a lot of cases, the performance is neck and neck with something like C. Now, there's no two ways about it that C and C++ and of course assembler programming is faster. And if you want to have something which runs really slickly and really fast, then usually a modern C compiler will outpace anything. But for 90% of what we're doing, the Python is fast enough, and the advantages in the actual programming is quite considerable. So in its most basic form, if I here I am at a command prompt here. I'm using a Windows 10 machine here, but I'm also today going to be using Raspberry Pis, which are running Linux. I'm going to be running using a Linux laptop to show you some stuff with an RTL dongle. So there's all of this works in all different operating systems. It's not dependent on the different environments. But if you go to a command prompt and you type Python, then so long as it's installed, then you should get what's called the REPL, the it's basically the actual interpreter is now running inside this command prompt. REPL stands for what does it stand for? Something. You know, I can't actually remember, but it doesn't really matter. You don't need to know, but it's called the REPL, R-E-P-L. So this is actually now the interpreter. So what that means is that I can actually type in live commands. Now, this is something you simply can't do in other compiled type languages. So in here, I can say, for instance, hello world, which is the most obvious one. I can say print, and I just say hello world. I do that, and there you go. So that is the hello world problem sorted out in one line of code, and it executes absolutely immediately in line. So I can do things like A equals 1. I can say B equals 2, and the interpreter is actually now building up a small, I'm going to call it database, but it's not. But it's building up an actual thing called a dictionary of all of these objects that I'm talking about. So all the time I'm using it, it's building up this knowledge. So if I now do A, it will show me the value of A. If I do B, it'll show me the value of B. And I can do things like A times B. And so you can use it as a calculator. So it's not a particularly good piece of maths, is it really, that 1 times 2? I mean, it's not anything exciting. But if I do A divided by B, then that's a bit more exciting. There you go, you get a floating point number now. So if I wanted to assign that to a third variable, which I might have a variable I want to call C, I can say C equals A divided by B. So if I do C is 0.5. Now the cool thing about Python is that you don't have to do what's called typing. Pretty much all of the language, well, I'll say all of the languages, there are some that have come along since Python that have seen this as being a good idea. Python has a typing mechanism which is called duck typing, which what it means is that if it looks like a duck and it quacks like a duck, then it's a duck. So what does that mean? Well, if I do A equals 5, then A is an integer value. So if I do type A, it will tell me what A actually is, because everything in Python, as I was saying to you a minute ago, is an object, or rather, it is an object-oriented environment. But literally everything in Python is an object, and that is something you need to take on board when you first start learning about Python. So if you can find out what type any object is by just using that keyword called type. So you can see that that A is in fact belongs to a class of is an integer. Int means integer. Now, if I do A equals hello, okay, well, if I just do A, now you can see that A is now equal to hello. Incidentally, there's an interesting point there. You can see that I typed it with double quotes. It returned it with single quotes. Single quotes and double quotes in Python are completely interchangeable. You can take your pick which one you use. It doesn't matter. Obviously, you have to use them in pairs. So you can't use a double quote at one end and a single at the other. It doesn't like that. But you can use single or double quotes. But A now isn't an integer anymore. So if I do type A here, then you'll see that A is now a string type, str. Now, in other languages, you have to dictate what those are, and your variables are fixed at that point. So you can't actually change a variable. Whereas in Python, at any point, you can define a variable, and it will automatically, using this duck typing method, it will automatically create the type of variable you need. So that makes it super simple compared to other languages. If you know C, you'll know that you have to spend quite a while at the beginning of your program making sure that you've got all the variables all defined with the right types. In Python, you don't need to do that. And you can define variables as you go along on the fly. It doesn't matter. They don't. In fact, you're not even encouraged to put all your variables at the beginning of the program like you are in other languages. You are sort of encouraged to put them where they make most sense. So keep them together with the other code so that people can understand what those variables are and how they relate to the actual code that you've written. Right, I'm not going to carry on much further in the REPL. I'm going to start using another way of showing you how this code runs. But the good news about the REPL is that you can run it on any machine that it's installed on. You can just type the word Python and you're away, and you've got that ability to type in commands. Everything that you do in Python should work in the REPL. You can test things very quickly. If you want to know, if you're a bit unsure about, the syntax, or you're trying to print something out, maybe something a little bit more complicated, you might want to say the value of A is equal to, and then we can do. I'm going to use a thing called the format command now, which I'll come on to later in detail. But if I do that, and maybe you haven't got quite the, I'm going to get a syntax error then because I put too many. In fact, you can see that it's very politely put a little caret next to this here to tell me that I've made a mistake. So I can bring up the previous command by using the up arrow on my keyboard. I can delete that and then try it, and there you go. All right, the reason why it hasn't printed that out again is because I should have a placeholder here for the value. So the placeholder using the format command is a pair of curly braces, and now that should work. There you go, the value of A equals hello. So you can see, in fact, there was a perfect example. I made a syntax error, I made an error in typing something in, and you can test these little simple things out in the REPL. So it's great for that. So when you're learning, having the REPL is an absolute savior, because even if you're working on a bigger program, sometimes you can't sort of see the wood for the trees. If you just break out for a moment into the REPL, you can try something out like this and go, right, I know what it is. I forgot to put these braces in, so that was my mistake. And then you can go back to your main program and put those in, and off you go again. So that's something I do a lot of when I'm developing bits of software. So let's just put that away for the moment. Now, what I am going to be using to show you the rest of or a lot during today is I'm going to be using a thing called Jupyter. Any of you that are had anything to do with their academic work in the last 5 years will know exactly what Jupyter is. Jupyter has become incredibly popular in the science community, and especially the education, the academic side of science, because it's a form of notebook. If I can show you some here, it's a form of notebook, so it allows you to. It's a bit like a word processor in the sense that you can type text in, and you can put diagrams and images, but you can also put your code into these notebooks, and the notebooks are actually active. So you can, if you publish a paper about how you derived a certain conclusion from a set of data, you can put all of the actual working methods. You can see examples of that sort of thing going on here. You can put the an explanation of what you did. You can write some code, and you can run that code, and you can generate plots and graphs and diagrams, and it basically makes into if you want it to be, it becomes a completely interactive and active demonstration of an academic paper, if you like. So it's become incredibly popular because it means that you can hand that out to all your peers. They can mess around with your code. They can analyze your data. They can obviously properly peer review whatever it is that you're presenting. I mean, you can get very sophisticated with interactive controls like this. The huge amount of capabilities within Jupyter. You can also, there's a new or a relatively new plugin for it as well, which allows you to, it's called Voila, and it allows you to turn it instantly into a web page if you're wanting to make present it into a more public type of environment where you don't necessarily want people to play around with it. You can use Voila to publish that. So there's a lot of great work going on with Jupyter. All you do is it's obviously completely free and open source. To install it is really simple. It's just a case of the usual pip install Jupyter Lab. That's it. That's if you've got pip on your machine, which I would definitely recommend if you haven't already, that you install pip. Once you've got pip, you just do pip install Jupyter Lab. That's it, and it does everything else for you, and then you're away. So I've got Jupyter Lab running on my machine. In fact, that's the server there. So you actually you run it from a command line prompt, and you just type Jupyter notebook into the command prompt, and it runs basically a web server on your machine, which services the notebooks themselves. It sounds a bit complicated, but it's very simple in real terms. Let me just got the blooming thing. Right, where are we going? So sorry, I'm muttering to myself because I've got the Zoom, what do they call it? You know, the what's going on here? I'll tell you why it's showing. The Zoom thing bar keeps coming down and obscuring my screen, but it's because people are sending me messages and I'm not reading them. Sorry. Is Python the modern read, eval, print, loop? Oh, thank you. Yes, REPL stands for read, eval, print, loop. That's it. I did know that. It's just that it's information that sort of comes in at one side and gets pushed out at the other by other information that I need to remember. That's something that you can look up, I suppose, isn't it? Somebody's also sent a link to everybody. I don't know what that one is. Dare I click on it? Does it Google something or other? Let's have a look. Oh, sorry, it's the same. It's got a Wikipedia page even. Thank you very much, whoever said that. Right, so let's go back to here. Let me just put the chat thing away. Go away. What are you doing? Stop it. Thank you. Where are we? Where are we? Jupyter. There we go. So that's the home. This is my Jupyter notebook set that I've posted onto GitHub for you to use. What we're going to do is we're going to start using it. I've got a section here about Python, just basic Python stuff. And I've got a confession to make. I have taken quite a few of the introductory stuff I've taken from a course which is run at Delft University, or Delft Technical University, or TU Delft, who are actually one of our customers work. Very nice bunch of guys. And one of their guys in their computer science division has a course on it's called Exploratory Computing with Python. So it's actually exactly what we all need to know about with regards to processing our data and presenting our data. So these are notebooks which I have stolen. I've left all of his details on there, so that's all he asks if you do use them. I have created some of my own notebooks as well. You'd be pleased to know I have actually done some work towards this course or this workshop. But there's a load of good stuff on TU Delft's website, and a load of good Jupyter notebooks as well. you'll find these Jupyter notebooks on lots of academic sites. If anybody's doing any research these days in anything science related, usually there's a notebook around explaining how it goes. Should I go and install Jupyter Lab on my Raspberry Pi 400 to follow your course live? I've never installed Jupyter Lab on a Raspberry Pi 400 before, or any Raspberry Pi. I'm led to believe it will do it, but you might end up spending a little bit of time scratching your head and reading blog sites to get it to work. So you might find it a little bit distracting, but if you want to, yeah, by all means have a go. As far as I understand it should run on it. So this is an actual Jupyter notebook, and Jupyter notebooks are made up of cells. These are, I'm explaining this now. You're going to fairly quickly pick up the idea of how they work, but just as a very basic thing is that they have these cells. So this is a cell, this is a cell, this is a cell, and these cells have different modes. So a cell can either be, and there's a pull down here, it can either be Markdown, which is what this is. Now, Markdown is just a text formatting language. It's very nice, very simple. It allows you to do reasonably nice presentations like this. That if you want to see, there is actually a good help in here, so that you can go in here and you can have there's a help for Markdown. So now, if I double click this cell, it will take it into its raw form. So that is Markdown. So if you want a title, you put ## in front of it. If you can put 1#, 2#, or 3#. There's 3 different title styles. You put double quotes around things. It turns to it puts them into italics, I think. Let me just run that cell. No, it doesn't. They are just quotes. If you want italics, I think you put single quotes around it. So if you double click that, you get the actual raw Markdown. If I run it, you see there's a button there that says run. You can either press run, or if you're in a cell, you can press Control and Enter, which is quite often what I use. And it runs the actual cell. So in the case of Markdown, you see it formatted in its true form. This cell here, however, is a code cell. And you can see here it says code. So you can change any cell from a code to a Markdown cell. There are also heading cells and raw cells as well. I'm not going to talk about those, but the 2 principal ones that everybody uses are the Markdown cell for text and the code cells themselves. So code cells are just the same. I can hit the run button and it will run that. Now, as you saw in the REPL, the way that these cells work is the same, is that the very last value that is returned at from the very last expression in here will appear on the actual output. So you can see how that says out. It's subtly different from saying print. If I put this in a print statement like this and I run it now, you'll see it just says 12. It doesn't say out, because I have actually captured that print statement, or rather I've captured the value with the print statement, and the return for that is the actual output. So it's ever so slightly different from where we started out, which was that. So each of these cells I can run by clicking on the run, or I can hit Control Enter. You double click in them and you can edit in them, or if they're highlighted in blue, you hit return and you can then type inside them. So you can you can work from the keyboard, and if you're actually writing these notebooks, they're very fast to write. It can all be done with keystrokes. You can bang one of these things together really quickly, and they are exactly what they say. They are notebooks. So if you are working on something and you're developing some code and maybe some electronics to go with it or whatever, it's really useful. It is a notebook. You know, you can, as you go along, you can make notes and you can put bits of code in there, and you can put diagrams from you know, maybe electronics, you know, components and things like that. So you can use them as a notation system as well, but you can also run your code in it, which is what we're using it for here. So the next cell down, we're talking about a style. You can see here that you can have spaces in there if you want, and it looks nicer than when you don't. So those are stylistic things. There is actually a document available called PEP8, and if you're interested in the styling of your code, then have a read of a document called PEP8, which describes how you should program in Python. If you want other people to admire your work, as it were. It's quite a humorous and interesting document, actually, and it does give you some helpful advice. So this is a bit like we did in the REPL. So we've got A equals 6, B equals 2, C equals A times B, and then print C. Now, the print command can be used in all sorts of different ways, but basically whatever is between it, because it's an actual function, it always has the parentheses around it. So from a point of view of syntax, you have those parentheses, and anything that's in between those parentheses, it will print out. Now, if you have several things that you want to print, you can do that by putting a comma between each of the sections. So this is an actual, what's called a string literal, or you know, it's actually a string because it's got the double quotes in it. So it will print literally C equals. The comma then says, right, that's my first bit. My second bit is going to be the value of C, and it automatically will convert that into something which will be printable. So if I, why has it got C in there? Oh, I know, to show you the difference. So if I run that cell now, you'll see that, and this is what I was talking to you about earlier about the output. You can see how the print statement is this one. There we go, and we can put C on the end, and it will also output that because it's the last element on there. It will print that out, and it will say out next to it. You'll notice that in Jupyter Notebooks, that whenever I run these cells, a number appears in this box. What that means is that that's the order in which I are running these cells. So the order in which you run them is important, because remember what I said when we were looking at the REPL, is that the interpreter is building up this dictionary of all the objects that we're using. So at this point, it knows about A, B, and C. If I go into the next cell, it still knows about A, B, and C. In fact, you can see that because I've got print A and print B right away. There's no reference to A and B there. It's coming from this cell. So if I run this now, then it will produce the right output. Now, the only reason for that is because I'd already run this cell as 4. If these cells get out of sequence, so if I go up here, I'm going to go up here and say, clear all my cells. If I come down to this cell now and I try and run it, you'll see, oh, it does actually work. Oh, I know why. Yeah, sorry. There's another reason for that. The kernel itself, I need to restart the kernel. So if I restart the kernel, if I try and run this now, it will actually fail. It's not running. There we go. And it says name A is not defined. So the very first line of code is not right. And the reason for that is because A was defined in this previous cell. So if I go up here and I do run, that one's now run. I can now come down to this one and I can run it and it will work fine. So that's what these numbers are for. It's the sequence of which you're using to run the code itself. Does that make sense? Oh, got some more questions. Sorry, guys. PEP8, yes, PEP8. Okay. Thank you, Paul. I've got helpers. I like it. What are we doing? Good. So this particular section here, we're printing the A and the B out, whereas you can see there, C equals A times B, D equals A divided by B Yep, you can, we've already done that. Print C, print D. And then I'm also doing printing out the types of these objects to show you that they're both integers. Whereas C, if we do, sorry, D, no, we're making it back into an integer, that's why. So if I just do that and run it, then you can see that we've got an integer float. So that's a float now. So you can actually force it back into an integer by doing int. And by doing that, it will, as you can see, it becomes 3. It just becomes 3. Whereas if I remove the int from there, which forces it, it then becomes 3.0. So the number doesn't change, but the had it been a different calculation. So if we make let's make this 5 instead. If we make that 5 instead and we run that cell and then we run this cell, you'll see now that this is 2.5. So if I put int into here, this will just become 2. It truncates the 5. You lose the 5 because I'm making an integer out of it. So no floating point. So just bear that in mind. If you try and force something, force a floating point number into an integer, it will truncate it. Now there are ways of obviously doing that in rounding it up the right direction, but in this instance, 2.9 becomes 2. The way that works. So, but if you ever want to know what the type is, just use type and the object, and it will return that type for you. What's that saying? You can add some text to the print function by putting the text between quotes. Yeah, we've already done that one, haven't we? Let's just run that. But the value of this is 5. So I showed you that earlier. So that's sort of making up a string within the print statement with a and also some other text, so you get a sense of something sensible. This is just for people that have come from C. If you want to raise to a power, you have to use ***. So some of the some of the functions are subtly different. Now, the nice thing about these notebooks, there's also exercises in here. Now, I'm not going to do these exercises, but these are I'm leaving them there for you to do. So if you are new to Python, you might want to come in here and just practice on some of these. So they've given you an exercise here. The nice thing is that if you get stuck, you click on the answer and it has the answer there. And it also has a link to take you back again, which is also very nice. This guy, what's his name? I can't remember. He thought of everything. Division works as well, as it says here. So you can divide, and you can see that this is a more compound command. So we've actually got an actual mathematical calculation within my print statement. So you can compound. Python will allow you to compound most commands, and if you get to a stage where it doesn't like it, it will tell you. It will say this is you can't do this compound command in that way. In which case you'll have to break it down into smaller sections to do the calculation or whatever it is you need to do. But that is perfectly acceptable. And as you can see, it works fine. It works to I don't know how many decimal places, but it enough. That's about Python 2. I'm not going to go into that. Now, the format command is a very, very useful command. The way that these print statements work is fairly rudimentary. The one with the commas, the way that these are done, they're okay for when you've got one or maybe 1 or 2 bits of information that you want to put together. By far the best way, in my mind, is the format command. This one here, and the way that the format command, format is a method which belongs to string types. So if you have a string type, like for instance this string here, and you do a dot, that allows you access to all of this. This is standard object-oriented programming now. So you have the actual object, you do a dot, and then it allows you access to all of the actual methods belonging to that actual class. And one of the methods is called format. Very, very useful. The format method, which belongs to string types. And what it does is it allows you to put these placeholders in your string. You can see how we've got these braces in here. And then you can pass the variable names in this section here. So it works sequentially. So A will go into that placeholder, B will go into that one, and C will go into that one. The nice thing about it is that it doesn't matter what the type is here. So it can be a float, it can be an integer, it can be a signed integer, it doesn't matter. It will automatically render it for printing. Well, that's the big advantage of the format command. If you only want 3 decimal places, you can do that as well. In fact, I'm going to show you that fairly quickly. Now, if you're using Python 3.7 and above, which I am here, I think this is 3.8. There's also a thing called an F string. So it's a relatively new thing, is the F string, and it won't work on some older versions of Python. So don't be surprised if you try it and it doesn't know what you're talking about. But the F string has turned the format into a sort of inline command. So it's exactly the same command, but this is an F string version. So you put an F in front of your string to say it's an F string, and then you put the variables actually in the parentheses. I don't know why they didn't think of that in the first place. It seems a lot more obvious, doesn't it? Now you see it. But F strings are a great thing. I tend to use a lot of the format method simply because a lot of the systems I work on at work aren't yet running on Python 3.7. They're still running on 3.5, a lot of them. So we've just brought out some new firmware which is going to 3.7, I think. So or 3.8, I think. So I should be able to start using printfs, but I've got a habit of using format. But if you're new to Python and you're not using an existing code, then just start using the F string. I would. Let me just run that cell and you can see what the results are. So you can see that we've got 1, 3, a divided by 3. So we get this floating point value. So you can see 1 divided by 3 gives, and you can see how those two relate. And the results are identical between these two. Take your pick. As I say, you're going to see me using that a lot today, but I would get your teeth into that if you can. If you don't want all of this in here, then that's quite easy to cope with, because the format command allows you to put formatting in these braces as well. So before, this was just a C. If you look in this version, the one above there, that was just a C. But if I put some other characters in there, now this is a little bit, when you're new to programming, you're going to think, what the heck's all that? Well, the good news is that you can look that up. You can Google for the format command, and it has a list of all of these different things, and slowly you sort of get used to them. F means floating point. The 3 means 3 decimal places, or .3 means 3 decimal places. So 10.3 means a width of 10 with 3 decimal places, and .3e means 3 decimal places, but with scientific notation. That's what the E means. So let me just run that and you'll see what the results are. So that's the first one, 3 decimal places. That's the second one, which is 10 wide with 3 decimal places. So that's useful when you've got where you want to have a table that all sort of aligns, and you can use that width command as well. And obviously the last one, which is in scientific notation. So that's where the format command really comes into its own, when you start being able to format these values in your print statements. Makes them look, it allows you to present them in a nicer fashion. Nobody wants to see 9 decimal places, especially when they're recurring. Another exercise for those that want to play it, that want to cut their teeth, a bit mathematical based, but I don't think the maths is even not quite beyond me. So just reiterating what I was saying earlier about when you run when you create a variable in Python, it will remain in memory, so it can be used by all the other cells. And that's true when you're writing a program as well. So as soon as you declare a variable with a value, it is then available to be used by other parts of the program. What we're not going to cover today, really, not only loosely, is scope. And Python has, yeah, I'm not going to go on about scope at this point. It's too complicated. Is it case sensitive, as I noticed C and C? Yeah, that's a very good question. Is it case sensitive? Yes, it is. Absolutely. Everything in C is case sensitive. So if I change that to A, that would fail because it only knows lowercase a. It doesn't know, unless obviously I have a variable called A. So A equals, you can see that that's actually case sensitive as well. So if I actually run that, the value of A is something. And if I do it as an A like that, you'll see it's 1. So that's 2 variables now. And that is something that there's an easy trap to fall into, that when you're learning Python, if you come from other languages especially, is that if you make a typo when you're referring to a variable, rather than saying, oh, hang on a minute, I think you've made a typo, this isn't the variable I think you meant to use, it goes, the interpreter says, oh, I've never seen this word before, it's got a different character in it. I know, I'll give you a new variable. So you end up with a new variable with some of the value in it. That can catch you out if you're not careful. You can stare at that sort of bug for quite a long time. So I'm going to show you I'm going to show you some programming tools which help alleviate that problem. You need to program in environments which use IntelliSense, basically. Or rather, sorry, auto-completion. So all of your previously used namespaces is the official term for them. So any namespace that you use, it automatically shows you them and it corrects the spelling, as it were, if you manage to get one of the cases wrong or spelling wrong. So yes, be careful with case. And the names, make sure your names all are identical to the ones that you obviously intend to use. So that was a good point. So we know enough of the basics here to start to play around with plotting. It seems that we've arrived here relatively quickly. I'm just going to break away about this at the moment, because we're going to start plotting fairly quickly, actually drawing graphs on the screen, because obviously just playing around with numbers like this is pretty dull, but it allows us to understand some of the basics of Python. I've actually got somewhere working with libraries. I've got another notebook here which I created. Let me just clear this cell. Clear. Okay. What we're going to start to use in a moment in our Python program are what are called libraries. Now, libraries are other bits of code. They're either there are 2 types of library. There are what are called built-in libraries, which are there all the time. And then there are non-built-in libraries, which, and with a non-built-in library, you actually have to import them into your interpreter. So a typical one is the library, which unfortunately is American, uses American spelling, is math. It contains all of the mathematical elements which are more advanced than obviously we've used multiplication and division, but if you want to use anything more sophisticated than that, then it's in a library called math. It was called math in C, and I'm sure that's why it's called math. By the way, for those of you that don't know, Python was written by a chap called Guido van Rossum, who is a Dutch guy, and he wrote it for his PhD as an exercise in creating a new language for a PhD, and he sort of caught on. Clever guy. But he's Dutch, so there's a lot of sort of Dutch influence in here. And of course, the Python is reference to Monty Python, not to snakes. There's a lot of Monty Python references in Python if you look hard enough. So if you want to import one of these libraries, you have to use the import statement. So that import math does just that, and that's all that's actually done is imported the math statement. We have a question. Yes, case sensitive. Right. So what math has actually done for us has brought in a whole load of other components into our program, which we can now use. And in order to use them, if you want to see what they are, then there's a couple of ways of doing it. The first, well, let me just use math.py first so I can show you what actually happens. If I do that, what happens is that it gives us the value of pi, so it's obviously just a constant, which is part of this math module, and allows us to print that out to a bit of decimal places that we've asked for. If you want to see all of the objects which are in math, then there is a command called dir, which you can use on any object. So all libraries and functions support the dir command. So if I do dir math and hit that, you'll see that it prints out all of the contents of the math library, or when I say the contents, all of the actual functions, methods, attributes that belong to the math module. And if you look through there, you should find pi. There's pi there. So it's also got things like sine and cosine and tangent, and so you can recognize all of the mathematical functions in there. So it's a sort of scientific calculator component, if you like. There's another way of seeing what these are. If I go back to this cell up here, when you're typing in Jupyter Notebook, if you type in math and do a dot, if you hit the tab key, which I just did, it actually then produces a list. So these are all these same objects. You can see them all in there. So if you've forgotten what they are, you just do math dot. You can go down and find what you're looking for, because sometimes you think, oh, I can't remember what it's called, or what's it, you know, how do I return the power of something? Oh, I know. And you might type in power and it says, no, don't know what power is. So if you do math dot, you go down, yeah, pi, there we go, that's the one I was looking for. So that makes things a little less difficult or easy to remember. If, however, you want to see the whole lot, you can. Another thing you can do is you can, in Jupyter Notebooks, you can do question mark like that. So I can do math.py in there, and it will, if I run it, it pops up a box at the bottom, actually. You can see it here, and you can make it a bit bigger by doing that. Oops, that's a bit too big. Just as I went to get rid of it, someone chatted. Is there a Python command to see libs available for import use? Is there, hang on a minute, I can't get rid of this bloody thing here. So the question is there a command to see what libraries are available to use? No, because there are, there are literally thousands of libraries, and of course you can install your own libraries as well. So with regards to built-ins and non-built-ins, if you go to python.org, it does show you what they are. It depends on the interpreter that you're in. So when we later on play with a Raspberry Pi Pico, it's going to be a lot less than there are on this PC, for instance. I think the dir command. Yeah, there you go. So that is all of the ones that are in the current interpreter that I've imported. If I do built-in, no, I don't. It'll allow you to see all the ones that you've imported, all the ones that are from a package. No, it does. There probably is a way, but there are so many. Yeah, that's. There's somebody here telling me how to do that. Yeah, exactly. Yeah. So I mean, PyPy. You remember earlier on I was doing pip to install. Telling you to use pip to install Jupyter notebooks. Well, pip is part of a project called PyPy, and it is there's a huge list of libraries in there. Obviously, I use a math program called WX Maxim. Is based on Python as very similar. Right. Okay. Yeah. Obviously, a lot of the things I'm showing you in Python obviously aren't. They've been derived from other things. They're not necessarily unique or special. We're just about to start using a module which is very much like MATLAB, but it isn't MATLAB. It's an open source free version. So there's a lot of similarities simply because obviously they want to accommodate people coming from different environments. It's just gone past 10:30, so let's have a break, shall we? I think we could all probably do with a quick coffee. So if we say a 5-minute break, I'll go and make a cup of coffee, and I'll see you back here in what time we're on. We're on 10:37. So if I say, shall I say 10:45? Back here at 10:45, yeah? And we'll carry on. Okay. Any questions? Well, before we I don't know who that is, but I can't hear you. If you are asking me a question. No, right. I'm going to go for a coffee. That's it. That's official.